Hi, welcome once again to the class. And I hope you are preparing for the exams. You are practicing your math and your science. Yeah, so that this time, when we get the questions, we should move to what? To solve. Now, today we're going to look at something interesting, which is surface area and volume of solid figures. We are going to look at the surface area and volume of solid figures. So this is what we're going to look at today. Very simple, very short. Just hit on the point. You do more practice, then you'll be able to solve this in case we get a question on surface area and volume of solid figures. Now, for figures, we can have solid figures or plane figures. Plane figures are 2D shapes. Plane figures are 2D shapes. And for 2D shapes, we normally find their area and the perimeter. So normally you get something like a square, a rectangle, parallelogram, trapezium, rhombus, kite. These guys are what? Triangle. These guys are plane figures. Now for plane figures 2D, you can't hold them in your palm. You cannot hold them. But we talk of solid figures. These are figures that we can hold here. These figures are in 3D. 3D means physically I can hold, I can put something and they can contain something. That is why here we find their surface area, because they have surface area and what? And volume. So anytime you hear solid figure, a cuboid is a solid figure of a rectangle. So the 3D shape for a rectangle is what? Is the cuboid. And that of the square is what? Is the cube. So you should know some of these things. So what we are coming to deal with are shapes in what? In 3D. So 3D shapes we are coming to deal with. Now, the shapes we will deal with today, we'll look at the cylinder, we'll look at the cone, we'll look at the pyramid, cylinder, cone, pyramid, we'll look at the pyramid, and the sphere. So these are the shapes we are going to deal with. And the cuboid, let me add the cuboid to it, and the cuboid. So these are the shapes I'm going to deal with today. Now I'll start with the cylinder, go to the cone, the cuboid, the sphere, probably come to this. But these are the shapes that we deal with when it comes to the solid figures: cylinder, cone, pyramid, sphere, and what? And the cuboid. And at times the cube, so we can do this, and the cube as well. So they are all on the same plane. So look at that. Okay. Now, under each of these we are just making it very quick. So under each of these, we are going to find certain things. In the exam, there are certain things to ask you to find concerning these guys. One, we are going to look at these guys' total surface area. So look at how to find the total surface area. Now, why total surface area? Because this guy is a 3D shape. So of something of this sort, you see that we have to find this face, that face. So it will have many faces. Hence, we need to find what? The total surface area of this thing. Then, because it's a solid figure, it can contain something. So we find what? We find the volume. We find the volume of the figure. So we also find the volume of the figure. So these are the things. And if the figure has a curved surface, then the third one we are going to add up to is the what? Is the curved surface area. Is the curved surface area. Take note. Under each of these shapes, under each of these figures, I am going to find, or we are going to look for the total surface area. How many faces does the shape have? Then we find the area of one face, then we add up. Then we look at the volume of that figure, then what? Then the curved surface area. This goes for those with curved surfaces. So we can find the curved surface area for a cylinder, for a cone, for that of the pyramid, for this, but for the cuboid and the cube, they are not curved. So we can't find the curved surface area. That's what I'm saying here. Yeah. So in any question, I'll show you some tricks that you need to understand anytime you have such questions. And you can do this thing. Okay. So without wasting much time, once we have said this, we are going to take this cylinder and see how we are going to find these guys. You get the point I'm making here? The total surface area basically means that we should add all the area of the faces. So for total surface area is the what? addition of the areas of each face of the figure, That means that if the figure has 6 faces, I'm going to find the area of all the 6 faces and add it together. If it has 3 faces, I'm finding the area of what? Of the 3 faces and adding them what? Together. That's how I find the total surface area. Generally, for volume generally equals what? Equals the base area times what? The height. So keep that in your head. That volume generally is the what? Is the area of the base. So base area times the what? The height. And one thing you should know about height always makes an angle of 90 degrees with the base. Anytime you see a drawing in math, and there is this one and another line, once the line makes an angle of 90 degrees, this is the height. That is why parallelograms don't have what? Height. If you look at the parallelogram, normally the question must draw the height for you. Why? This side does not make an angle of 90, hence it's not the height. You get the point I'm making? So the height is always perpendicular with the base. So in any case, when we are finding the volume of a figure, we look at the shape of the base. Is the base circular? Then we'll find the area of the circle, then multiply by what? The height, so we can know its volume. So that's what we're going to do. So basically, that's what we do for each one of them. Good. Then the curved surface area, we look at those with the curve, how to find the area. Normally, the circumference times what? The height. Look at the cylinder, the circumference, the area around it times what? The height. So let's jump into it. So we'll first of all take the cylinder. I said under each one of them, we'll find what? We'll find the total surface area, the volume, the curved surface area for each one, or for those that are what? Are curved. So let's start with the cylinder. So for the cylinder, we have a milk tin is a perfect example of a cylinder, or a Milo tin is an example of what? A cylinder. Now, if you look at a cylinder, if you have a milk tin, you can go and bring it. If you look at a cylinder, we'll have 3 faces. 3 faces here. We'll have this face, which is the top there, that face, and also the side, the curved surface area. So for cylinder, from here to here is our height. Now this thing looks circular. That means from the center of this to there becomes our radius. Right? So I need the height and the what? And the radius here. Good. So I want to find the total surface area of the set. For each of them, I'm going to find the total surface area. But when it comes to this, there are 3 conditions under which we can find the total surface area. Remember I said earlier that for the total surface area, we look at the number of faces available. In the question can give us a cylinder with both faces available, with all the faces available. I mean, this end and that end are there. So like a closed Milo thing is what? It's a full cylinder with both sides up, with both sides closed. So we are going to look at the total surface area, but under 3 conditions. 1, the total surface area of a closed cylinder. So 1, a closed cylinder. When I say a closed cylinder, I mean it is complete. No other side is open. You get the point I'm making here? I'm taking what? The total surface area of a cylinder. I said that we do it in 3 ways. We have a closed cylinder. For a closed cylinder, that means all the faces are what? Available. That means we'll have how many faces for that? That will give us 3 faces. Now if I look at the face, what do I have? I have the circle, then I have another circle here, then the curved surface area. So before I even write this, let me come and write down its curved surface area before I even write this. So that we can use that. The curved surface area of a cylinder, the curved surface area of a cylinder, what is that equal to? That equals, of a cylinder equals, the curved surface area is the distance around the wall, the tin, and the distance around is what? Is the circumference. So that will be the circumference times the wall times the height. So this will be the curved surface area of that. Now this circumference is the circumference of a circle. So what do I have? That will give me 2 pi r times what? H. That means the curved surface area of a cylinder equals 2 pi RH. Note this. And be very mindful, this is the curved surface area. This is the curved surface area. So that in the question, if the question already gives you the curved surface area, then there's no need to ask for radius. The question find the curved surface area of a cylinder whose circumference, the circumference has been given, whose circumference is 44 cm and height that. You just multiply the 44 by the height because they've already given the circumference. Take note. So not that you have, no. Don't expect them to give you pi, don't expect them to give you what? The radius, because they've already given you the circumference. Okay, so let's go. Now, so a closed cylinder with 3 faces, I said we will have 2 circles and what? And 1 curved surface area. How do we find the area of a circle? That gives us pi r squared. That is for this, and another one under pi r squared for that. Then 2 pi RH. Where is this 2 pi RH coming from? It's coming from the curved surface area. So 1 curved surface area and 2 circular parts. So this part and that part. So this will give me this, and these are like terms. I'll get 2 pi r squared plus 2 pi RH. Now these formulas are not necessary. What you need to know as a student is that, what am I doing here? I said the total surface area from the beginning is the sum of the individual faces. What face am I seeing when I take a milk tin? I'm seeing a circle, and a curved surface area. The curved surface area is the circumference times the wall, times the height. And then the area, this is what is a circle, so the area of a circle. So since I have 3 faces, it's not a formula work. Don't cheat the formula. Just understand what is going on. Since I have 3 faces, then I'm going to have this circle, which is the base, this one for the top, then the curved surface area. These ones are just simplifications. I'm simplifying. What do I do here? The most important is when I know this. But for the work to be easy, you don't do, when you're working and you do this, you are going to waste time. So we simplify this. But when you know this and you know your simplifications, you don't need the formula. Also, don't keep the formula there. Just understand how we get that. 2 is here, so I want to factorize. There's 2 here, there's 2 here, there's pi there, there's pi there, there's r there. R with the smallest one will come out. So I have 2 pi r into bracket r plus h. This will help you. So next time you're able to write this, make sure you simplify before you start doing your substitutions. Take note. Make sure you simplify the formula before you start doing your substitution. So this is one. Then the second one, we want to find the total surface area of a cylinder with one end opened. So here, one end is what? Is opened. If one end is open and you understand what I'm saying, then for this time, we are going to have this one off. Let me just use some assurance indicate that this one is not there. So if this guy is not there, we'll have how many faces? 2 faces. Very simple, man. We'll have 2 faces. What are the faces? A curved surface area, this and what? And a base. So this will give us the curved surface area, which is what? 2 pi RH plus just the base, which is what? Which is pi r squared. Here we have 2, but here one end is open. So we have that. How do I know one end is open? They normally use this one to show that one end is open. If the drawing goes full down with that means both ends. Sometimes you don't do it and they'll tell you that with one end open. Take note. So if you keep this formula in your head as a curved surface area and one end is open, you make a mistake. Then that's what I'm saying to understand. Okay, from here to we can do some factorization. There's pi, so pi out. There's r out. So I'll get 2h plus r. This will be the simplified one. Then for the third one, what are we going to do here? With both ends were open, so we'll go with both ends open. With both ends were opened. What do we do? With both ends open, that means that we don't have this, we don't have that. People, let's think together. If we don't have this and we don't have that, what are we left with? We are left with the curved surface area. Just the curved surface area. That means with both ends open, this will be equal to what? 2 pi RH, which is the same as what? As the curved surface area. This is how to find the total surface area of what? Of cylinder. I hope you understand what I'm saying here. I hope you understand. So take your time and go through and you understand. Don't change the formula, understand what is going on and be fine. Okay? Okay. So let's go on. Now I want to say something before we move on. But let me give the volume, the move on. So I won't clean this now. Let's go. I said for volume, for volume. So volume of a cylinder, I said volume is always what? It's always the base area times the what? The height. So look at the base area. What shape do I have? What's the area of the base? It's a circle. So the base area, volume is the base area times the what? Times the height. What's our base area? It's a circle. So we'll have pi r squared times the height, which is what? H. Therefore, we'll have what? Pi r squared h. This is how to find the volume of a cylinder. Now, this I spoke of it some time ago. Let me explain this. Please listen to this aspect of this. Generally, when it comes to math and there's a relation to finding a particular parameter, there is a relation to finding a particular parameter. What do I mean by that? Volume is needed. So let me say that's V equals this. So V, pi, r, and h. These are the parameters we need to find volume. Take note. Now, this is so 1, 2, 3, 4 parameters. In any question, since there are 4 parameters, the question must give you 3 available parameters. You substitute them, you do your calculation and find this what maths about. You see, once again, I'm saying that in any case, any of this, for this, the question is equal to the total surface area. The question must give us what? The value of pi, the value of r, the value of h, if they want us to find the total surface area for them. But if they want us to find h, let me use this, if they want us to find h, then they should give us the volume, the radius, and the pi, so we can find this. The point I'm trying to make is that in any relation, if there are 4 parameters there, the question must always give us what? 3. If there are 30 parameters, the question gives us 29, then we find the other. In the course of giving us what parameter we have, they can give it to us directly or indirectly. That's why the case, when they bring it directly, everybody can do this. But when it comes indirectly, that's why students fumble a little bit. But don't worry, that problem can be solved. I hope you understand what I'm saying here. You get this? So for this one, we found the volume, we found the total surface area under 3 circumstances. Then we've also found what? We've also found the curved surface what? Area. Good. So this is how we find, or this is how we deal with what? The cylinder. I hope you get the point I'm making here. Good. This is a cylinder. Very easy. Very easy. Now, we can also look at something called a pipe. Very simple. Let's look at the pipe quickly. The pipe. Now, for the pipe, take note of something here. So let's say this. Yeah, let me just sketch a pipe. So this represents a pipe. And you can see that for a pipe, we'll have our radius set. There's an internal one, and there's also what? An external one. If you take a pipe, any pipe hole, anything that has run, when you look at it, there's always an internal and what? An external. From the center to the internal circle, we use small r for that, so that's the internal radius. Then from the center to the external, we call that capital R. So that is how we find what? That is how we get this, the pipe aspect of this. Now for the pipe, you'll be told to find what? The cross-sectional area of the pipe and also the volume of material used in making the pipe. If you find the cross-sectional area of the pipe, it's very simple. What we do is we find the area of the wall of the external one, then we subtract the area of the internal from it. So for a pipe, we will be told to find the wall, the cross-sectional area. And if I'm finding cross-sectional area, I said the cross-sectional area will be the area of the external one. How do we find area? That will be pi capital R squared, because the R capital represents the external radius. Then minus pi R squared, which is the internal. This is how to find the cross-sectional area of what? Of a pipe. If you want to find the volume of a pipe, we'll look at that one too. Good. So let's go. So then, basically, if I want to do some factorization, pi comes out, then I'll get what? R squared minus what? R. Done. So this is one thing we can talk about the pipe. Then we look at volume of the material used in making the pipe. What material was used in making the pipe? So for the volume, it's one of the things you need to know. Volume of material used in making the pipe. Making the pipe equals, once again, we'll have the volume of the wall, the external, minus the volume of the wall, the internal. So this will give me pi r squared h, which is the volume of the external. I told that volume is the base area times the height, minus volume of the internal, which is pi small r squared wall h. So this is how we find the volume of the material used in making the pipe. The external volume minus the what? The internal volume. So finally, there's h, there's pi. So pi h will be out. So I have pi h into bracket big R minus small r. This is about who? The pipe. But if I have to find the volume of the pipe, because the water or whatever you put in the pipe, we take the internal one. This will be the formula for finding the volume of the pipe, not the material. If it should they pour water into this and tell that way and find the volume of it, it should be the internal, not the external. But the volume will not be on the external to cover the wall, the internal. All these things will be the material. You don't need all this. So the internal one. So you use this to find the volume and not what? And not the volume of the material. I hope you have gotten the difference here. Good. So let's move to the next shape, which is our cuboid, right? Let's go to the cuboid. You have to do more questions, practice more questions on this. Practice more questions. Once you understand, you should be able to solve the questions. Solve questions, it becomes very lengthy. But see if we can do one or two questions here. Good. So, like I said earlier on, for the cylinder, if that look at the curved surface area, the total surface area, and the wall and the volume. Let's take a cuboid. Now, so say this is my cuboid, neatly drawn. Let's get something. Yeah. Now the cuboid has how many faces? 6 faces. This one is not curved, so I can't find curved surface area. Take note. The cuboid will have how many faces? 6 faces. 6 faces. Let me demonstrate with this. Okay, so this is a cuboid. We have 6 faces here. I think I've numbered them. So this the first face, phase 1. Then I have phase 2. I have phase 3. I have this phase 5. So phase 4, phase 5, and what? Phase 6. If we are finding the total surface area of this cuboid, then we need to find the face of this, the face of that, the face of that, the face of that, and sum everything. And that's what we said earlier. So for the total surface area here, to be the sum of the 6 faces. So there's the first face, the second face, the third face, the fourth face, the fifth face, and the what? 6th face. We are going to find the area of the first, add it to the second, and everything that we get. Now, I'm doing this because it is not formula. When you understand this, and the question tells you that one end of the cuboid is open, then you should know that we omit one of the faces. But if you just choose the formula and you use that, and that means even if it's open, you are going to use this formula and you get wrong because the one is open. So if one is open, you also take one out. So if you understand it from this end, I'm going to add. So what will be the face here? So let's take phase 1. You can see now I've labeled that H and what? And L. That means the length times the what? The height. So for phase 1, according to this, we have length times what? Height. Let me just put it this way: length times height. Then let's look at phase 2. So for phase 2, we have the height times the breadth or the what? The width. So we'll go with that one. Height times breadth or width. So this will give us the height times the what? The breadth. Let me just use this. Then plus the third phase. Let's look for phase 3 here quickly. Okay, this phase 3. That is the length times the what? The height once again. So length times height plus, let's look for phase 4. That's phase 4. That's the breadth times the height. So we have the breadth times the height. Then plus, let's look for phase 5. That is what? That is the length times the what? The breadth. So length times breadth for this. Then the phase 6 also gives us what? Length. You can see length times what? Times breadth. So this also gives me the length times the breadth. Then I sum all this. So after doing this, all right there. This and I think some like them. So this is the formula. If there are only 5 faces, then one of them is out. That means this will be the formula. If there are only 3 faces, then 3 of them is out. So when you understand this, the question cannot be 2. But when you keep the formula in your head at the simplified stage, when they choose the question, how they choose the question, they say one end is open. They use the formula, you are wrong. I hope you understand what I'm saying here. So take note of that. This and that are like them. So I get 2 times of the LH plus, once again, 2 times of the what? Of the HB, then plus 2 times of the what? LB. I have this. What do? I can factorize 2 out. So I'll get 2 into bracket LH plus HB plus LB. This becomes the total surface area of a cuboid with all the faces given. All the faces. 6 faces. So I added all the 6 sides and I have this. If it's 5 faces, take 1 out. Any of them out, you'll be fine. You get it correct. Okay, that's what I'm saying here. Good. Then we'll find it. So this is the total surface area. Let me put it here. The total surface wall area of the wall of the cuboid. Then let's look at the volume. Like I said, volume is the base area times the wall, the height. So the volume is our base area times height. So volume of a cuboid equals what? Equals the base area times the wall, the height. So this will give me what's the base area? Base area times height. Now the question is, what's the base area? What's the base area? The base area is a rectangle. So that'll be length times breadth, a rectangle, then times the height. So times the h. And that gives me LBH. So this here is the base area. If you want to twist it, find the volume of a cylinder, or find the volume of a normal cylinder cuboid, whose base area is this and height is that. Whose base area? So you don't need length, you don't need what? Breadth, when you understand. The base area has been given. Once again, on the normal ground, there we have volume, we have length, and we have what? Breadth and height. So 4 parameters. In any question, 1, 2, 3 should be given, or 1, 2, 3. If the question wants us to find them the breadth, then they should give us what? The volume and the what? The length and the height. So that we can go and find this. That's what I'm stressing on. When you read the question, you write down the parameters. Very important in math. When you do that, math becomes easy for you. Whatever the question is, you need to write it down. That is, what do I have? Now, if I see what I have, it will help me to solve what I'm looking for. I get what I'm saying here. I know you're getting it. I know you're getting it. I know. Let's go. So for this, because there's no curved surface, this is how I'm going to leave it. Then let's try and put the cube here. For cube, what do we say? We are saying that for the cube, we have also, for cube is the same as the cuboid, but all sides are what? All the sides are equal. I've sketched something. It doesn't look like a cube. So for a cube, all sides are basically what? Equal. So let me try do some sketch for you. Let me try. Yeah. Okay, so at least I have a cuboid here, a cube here. All sides are equal. So if this is length, that's length, that's length. All the sides have length, 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 length. So therefore, we are going to also add what? 3, all the 6 sides. And one side, so let me say total surface area. Total surface area of the cube should be equal to, when we get one face, because they're all the same, when I get one face, I multiply by what? By 6. You get the point I'm making here. If there are 5 faces, I'll get 1, multiply by 5. This one is very simple. Just get one face and multiply by what? By 6, because all the faces are equal. Instead of going to do this one, they are different. That is why I'm having this. But for this will give me, what is the area of one face? One face, so 6 times the area of one face, which is length times what? Length. Now the area of one face. So that'll be 6 times L squared. 6 times of L squared. So 6L squared becomes the area or the total surface area of a cuboid. When the sides are closed, then the volume should be equal to what? Equal to the base area times the height. What's the base area? That's length times length. What's the height? Length. It's also L. So that will give us what? L cube. So this is for a cube. Very, very well. Very, very important. I hope you understand what we are saying here. Yeah, it's very, very important for you to get these things. In a question, there are 4 parameters. The question must give us what? Must give us 3. Then we find them the other. In the course of giving us, they can give us directly or indirectly. That's no problem. But for you to want to solve such a question, anytime you read a question after this, you are practicing, write down the height of S, write it down. Write it down. Everything, write them down. You get the point I'm making here. Good. Very, very important. Now, in the case of the cylinder, there are times they give you the diameter instead of the wall, the radius. There are times the diameter is given instead of the radius. In such a question, divide the diameter into 2 and you will get a radius. Why? Let me demonstrate that quickly. So just we have this. This is my center. That's the radius. This R, that's under what? Under R. And these two R's will give me a diameter, because when a line is drawn from one end to the other, going to the center, it gives a diameter. That means 2 times of R equals our diameter. So anytime the diameter is given, we divide the diameter into 2 and we have our radius. How do you understand what I'm saying here? So in a question where you are not given at time, they give it directly. That time the radius is this. But instead of giving the radius, they give you the diameter. No problem. You can still do it. Yeah, I hope that you get the point I'm making here. Good. So now let's go to that of a cone. A cone. A cone. Good. So for a cone, we have this is our radius. Now this cannot be the height, so we have to force to have the height for the cone. So let's give the cone a height, because I said the height should always make an angle of what? 9. So this is not the height. Rather, we call this L, which is the slant height. The slant height. So that's for L. And these are radius R, and these are all our height. Once again, because of the curve, because the surface is curved, we can find the curved surface area. We can find the total surface area, and we can also find the what? The volume of the cone. So let's go with the curved surface area. So the curved surface area, curved surface area equals pi RL. It's pi what? Pi R times what? Times the L. This is how to find the curved surface area of the what? The cone. Very simple. Now let's go to the total surface area. Total surface area. Now once again, the total surface area, we can have it in 2 senses or in 2 ways. One, when this side is closed and when that side is open. So we look at the total surface area, one, of a closed cone. So closed, of a closed cone. So for the closed cone, we will have what? The curved surface area plus the area of the circle, right? So that will give us pi R squared plus pi RL plus pi RL. This will be it. Why am I saying that? This is my curved surface area, which is this one. Then this is my what? The base, which is the area of a circle. So once again, I can factorize pi out. I'll get into bracket R plus what? L. This is how to find the total surface area when the cone is closed. Then for the second one, we have the hollow cone. Hollow cone. Hollow cone means that this end is open, so it's hollow. Therefore, that will just be the curved surface area. So this equals still pi RL, because there's no base. So keep that in what? In mind. There's not that the total surface area. Listen to what the guy is saying. Find the total surface area of the cone that is open, or that's what? Hollow. This is how we are going to do it. I hope you understand that of the cone. You understand that of the cone? Okay. So that is very simple for the cone. That's very simple for the cone. Then we look for the volume of the cone. So let's look at the volume of the cone. Volume of cone. Now, let's take this and see. Let's take this cylinder. I want to use the cylinder for something. Then you get to know. Now, how do we find the volume of a cylinder? That was pi R squared what? H. Pi R squared. You know the volume here. Now, when I do this, look at something for me. Look at something for me. When I do this, you can see that I have 3 cones. 1, 2, 3. I hope you can see. This is a cone, that's another cone. Understand? That means 3 cones will give you one cylinder. Hence, the volume of a cone equals 1/3 pi R squared H. 1/3 of what? Of the volume of a cylinder. So I can give you a question where the volume of the cylinder will be given, but I'll tell you to go and find the volume of a cone. When you know the volume of a cylinder and you divide it into 3, one of them becomes what? Becomes a volume of the what? Cone. So volume of a cone, according to what we've discussed so far, is 1/3 the volume of the what? Cylinder. So 1/3 of the volume of A cylinder. Very, very important. 1/3 the volume of a wall of a cylinder. That is for the cone. I hope you get this. I hope you get this. Okay, so that's about the cone. That's for the cone. Let's get to the sphere and the pyramid. The sphere and the pyramid. So I think you are getting the point for these guys. You are getting the point for these guys. Yeah. Very, very important for you to know them. Very, very important for you to know them. Okay. So let's rather solve some questions. Or let me also say this before we even continue. Now, there are times they can combine the shapes for you. You can get a cylinder. We call them composite shape. A cylinder with a cone. No problem. If I have to find a total volume, find the volume of the cone, find the volume of the cylinder, and add up. You get the point I'm making here. That's how you're going to do this. Find the volume of the figure. Find that of the cone and that of this and that. And there are these things they add up. Find when the cone is half filled, or when the volume of water in the cylinder is half filled, one third filled. Means find the volume and divide into what? 3. Half. Find the volume divided into what? Into 2. How can I thought I'm saying here? How can I thought I'm saying? Good. So let's go quickly. Let's go with our pyramid. Let me go with the pyramid. Quickly. So for a pyramid, let's see, we have something like that. Something like this. This is a pyramid. Okay. So the pyramid will have the height. We'll have height here for the pyramid. And let me give this. Now, for this a square pyramid. When I say a square pyramid, that means the base of the pyramid is a square. So for this to find the total surface, you can get a square pyramid, a rectangular pyramid, and what? And a triangular pyramid. Rectangular pyramid means that the base is a rectangle. A square means the base. So look at the base. You understand what I'm saying? And these guys are coming from the cuboid or the cube. So once again, if you want to find the volume, it's 1/3. The way I divided it for the cylinder, the same thing that will happen. So 1/3 the base area times the what? Height. That's what happened there. It was 1/3 pi r squared h. Pi r squared is the what? The area of the cylinder and the height. So once again, these guys cannot be the height. So these guys want to find the total surface area here. The total, hope you understand this, the total surface. Total surface area will be equal to what? We'll have 5 faces. 4 of the triangles, then the base. So the total surface area will be what? Will be 4 times the area of the what? Of the triangle plus the area of the base. I get what I'm saying here. Good. I said it is what? 4 times. So this area plus that, there will be 4 triangles. Then you add them, then you also add to the what? To the base. So there will be 4. So that'll be fine. So that'll give us 4 into bracket area of the triangles, 4 into bracket area of triangles, plus then we look at what? The area of the base, area of base. So that if you are looking at a square pyramid, a rectangular pyramid, a triangular pyramid, the area of the base will be the area of a rectangle. We can't specifically write one formula down. No, because it will differ. This is what you understand. I have 4 of that. But when it comes to that of the triangular, that means you have 3 faces. Take note. For the triangular, we'll have 3 faces. Because this is how the triangular pyramid will look like. Something of this sort. So 1, 2, 3 for this. Then the base, the bottom 2. I hope you get the point I'm making here. Very, very important. Now, if you have to find the volume of this one, volume of the pyramid. Find the volume of the pyramid. That is 1/3 the base area times what? The height. So 1/3 times the base area. Once again, I don't want to write a specific formula because the base area will change. So the base area times the what? Times the height. Very, very important. I can't write one specific formula because it will change. I hope you understand what I'm saying here. Good. Then a circle is a 2D. So right now I'm moving to the what? The sphere. Circle is 2D. In the 3D form, a ball is a sphere, like our Earth. The ball is a sphere. So get the difference here. A circle is a 2D, and the 3D for the circle is the what? The sphere. Good. So if I want to find the surface area, so look at the surface area of a sphere. Surface area of a sphere. So let's go. The surface area, everything of a ball. So the surface area of a sphere equals 4 pi r squared. Equals what? 4 pi r squared. Then we find the volume of this. The volume of this equals what? 1/3. No, 4/3 pi r squared. 1/3. Volume of a sphere equals what? 4/3, so 4/3 pi r cubed. Very important to know. 4/3 pi r cubed, where r is the radius of the sphere. Good. Very important. So you need to know this of the sphere. Normally the sphere and the pyramid, they don't normally stress on that one. The three shapes you can get is what? Is the cylinder, the pyramid, the cylinder, the cuboid, the cube, and the cone. Look at that one. Very important for you to know those ones too. Hope you are getting what I'm saying here. Very important. Good. Now let's come to we can have the hemisphere as well. When we say hemisphere, that means we divide this into what? Into two. If you want to know the surface area of the hemisphere, then that's going to be what? That's going to be, so for the hemisphere, we'll have half of what? Half of 4 pi r squared. The hemisphere will have half of that. That will cancel that. We'll get 2 pi r squared. That's for the hemisphere. Half of it, the surface area of the hemisphere. Then if you want the volume of the hemisphere, volume of the hemisphere will give us 1/2 times 4/3 pi r cubed. This will cancel that. We'll get 2/3 of what? The pi r cubed. So this is how to find the volume of the hemisphere. Now, I hope you have understood this. This calls for more practice. Based on all that I've said, you need to practice. Once you solve more questions on this thing, you'll be fine to go with. Hope you understand this. Yeah. So this is the end of what? Of our video today. Sit back, look at it very carefully, and do what? And solve more questions. If you have any question, let us know, and we are going to what? We are going to answer you. Thank you very much for joining today's class.